Let's say you see a balloon floating in the sky. How could you describe its position from you? There are a few different ways, but one method would be to measure the balloon's horizontal distance from you, let's say it's 5 meters, and the balloon's vertical distance from you, let's say it's 13 meters. You could represent these two bits of information by what we call a position vector, r. In this case, the position vector is written as 13 meters. Notice that all a position vector does is summarize the distances and directions needed to travel to get to a point. Even though this mathematical notation is enough, it's often convenient to visualize a position vector. This is done by drawing an arrow from the datum, i.e. u, to the point, i.e. the balloon. To make matters even more complicated, this vector can also be written in another way. R is equal to 5i plus 13j. I is called the unit vector in the x direction, and j is called the unit vector in the y direction. It's worth noting that in the general case, since we live in 3 dimensions, r is written as x, y, z, where x is the horizontal distance to a point, y is the vertical distance to a point, and z is the out-of-page distance to a point.